All right, so continuing with trigonometry, May 19th, 2020. Example 3. In example 3, we're given a right angle triangle and we know the length of the hypotenuse, which is 13, and we know the length of another side, which is 5. We're asked to determine the sine and the cosine, the sine, cosine, and tangent of theta. All right. Now, this is theta. Some things I would highlight. Everybody should remember that the side that is in front of the right angle is the hypotenuse. All right. The side in front of the angle is the opposite side. So over here is opposite. And the other side where the 5 is adjacent to the angle theta. So that's what we have so far. We have what? Now, carefully, if you look, you'll see that we have the hypotenuse, which is 13. We have the adjacent side, but what we don't have is the opposite side. I'm going to call it x. Now, if I know two sides of a right angle triangle and I wish to find the length of the third side, I must apply Pythagoras Theorem. So I'm going to start by applying Pythagoras Theorem, which says that c squared is equal to a squared plus b squared. That's a Pythagoras Theorem formula. And in the Pythagoras Theorem formula, c is the hypotenuse and a and b are the other two sides. So the hypotenuse here is 13, so c is 13. The other two sides are x and 5. So it's x squared plus 5 squared. 13 squared is equal to x squared plus 5 squared. 13 squared is 169. This is x squared. 5 squared is 25. Positive 25 goes over and become negative. So I have 169 minus 25 is equal to x squared. And so x squared is equal to 144. The opposite of square is square root. So x is the square root of 144. And so x is equal to 12. So x here is 12. And everybody should know, especially from the last activity that we did, that once you know the length of all three sides, it's easy, you can find any trig ratio. So the sine, which is opposite over hypotenuse, so the sine of theta would be the opposite side, which is 12, over the hypotenuse, which is 13. Now, cosine is adjacent over hypotenuse. So the cosine of theta would be adjacent 5 over hypotenuse 13. And finally, tangent is opposite over adjacent. And so the tangent of theta would be opposite, which is 12, over adjacent, which is 5. All right. So we were given a triangle, and for that triangle, I know the length of two sides. I knew the hypotenuse, which is 13. I knew the side that was adjacent to the angle theta, which is 5. What I did not know was the side that is opposite to the angle theta, which is 12. We were asked to find the sine, cosine, and tangent of the angle theta. Cosine is adjacent over hypotenuse, so I could have found the cosine of the angle. But in order for me to say what the sine and the tangent of the angle theta is, I had to find the length of the unknown side, and the length of the unknown side is 12. Once I know that the unknown side is 12, sine is opposite over hypotenuse, which is 12 over 13, and the cosine of theta would be the adjacent side over the hypotenuse, which is 5 over 13, and the tangent of theta would be the opposite over the adjacent, which is 12 over 5. Stay with me. Now, the next thing we're asked to do is we're asked to show that sine square theta plus cos square theta is equal to 1. And to the right, where they try to explain to us that sine square theta means sine theta square. So we are to show that sine square theta plus cos square theta, and that would be equal to, sine is equal to 12 over 13. So this is 12 over 13 square. Why square? Because it says sine square. We must show that sine square theta plus cos square theta is equal to 1. But sine theta is equal to 12 over 13. So sine square theta would be 12 over 13 square. Cos theta is equal to, the cosine of theta is what? 5 over 13. Let me change that. Over 13. So cos square theta is 5 over 13 square. All right, so what I'm going to end up with is square the top and the bottom. 12 square is 144 over 13 square, which is 169. 5 square is 25 over 13 square, which is 169. Now, if I'm adding two fractions and the denominators are the same, I simply add the numerators. So this is 144 plus 25 over 169. And this is 169 over 169. And 169 divided by 169 is equal to 1. Ladies and gentlemen, we were asked to show that sine square theta plus cosine square theta is equal to 1, and this is what we had to do in order to show it. All right, so I'm going to pause the video and then give you guys a chance to look at the next question. All right, so in example 4, we're asked to find the sine, cosine, and tangent of the angle alpha. All right, now the side in front of the right angle, everybody knows, is the hypotenuse. All right, the side in front of the angle is the opposite side, or the side that is opposite to the angle, and the other side must be the adjacent side. So that one we don't know, the adjacent side. Now, cosine is adjacent over hypotenuse. So if I don't know the adjacent side, I can't find cosine. Tangent is opposite over adjacent. So if I do not know the adjacent side, I cannot find the tangent of the angle. All right, so in order to find x, what I'm going to do is I'm going to use Pythagoras Theorem, because Pythagoras Theorem is used to find the length of the third side of a right angle triangle when the lengths of the other two sides are given. Now, the Pythagoras Theorem formula is c squared is equal to a squared plus b squared. C is the hypotenuse, which is 5. So 5 squared is equal to x squared plus 4 squared. This is 25 is equal to x squared plus 16. Positive 16 goes over and become negative, so 25 minus 16 is equal to x squared. Therefore, x squared is equal to 9. The opposite of square is square root. Therefore, x is the square root of 9. And so x is equal to 3. X is 3. So now that I know what x is, sine is opposite over hypotenuse. And so the sine of theta is opposite 4 over hypotenuse 5. Turning the page. Cosine is adjacent over hypotenuse. And so the cosine of theta is adjacent 3 over hypotenuse 5. Lastly, tangent is opposite over adjacent. And so the tangent of theta is opposite 4 over adjacent 3. All right, I'm going to write back sine. The sine of theta, it's on the previous page. The sine of theta is opposite 4 over hypotenuse 5. All right, and you all see me writing theta, nobody never correct me. It's not theta, it's actually alpha. So let's erase everything at the bottom here. All right, so the cosine of alpha is 3 over 5. The tangent of alpha is 4 over 3. And the sine of alpha is 4 over 5. Is 4 over 5. All right. Now, let us see what sine alpha over cosine alpha actually means. Sine alpha divide by cosine alpha. That's what it means. But sine alpha is equal to 4 over 5 divide by cosine alpha, which is what? 3 over 5. So this is going to become what? 4 over 5 multiplied by 5 over 3. Why? When you're dividing by a fraction, you change the division sign to multiply and invert.
Reciprocate.
Very good. 5 cancel the 5. So this is equal to 4 over 3. All right. Now, if you look carefully, you'll see that tan alpha is equal to what? Help me now.
4 over 3.
4 over 3. So therefore, sine alpha divided by cosine alpha is equal to 4 over 3, which is tan alpha. Ladies and gentlemen, we were asked to show that sine alpha divided by cosine alpha is equal to tan alpha, and we just did that. All right. So the next example is example 5. I want you guys to try that one. All right. So the final example in this section is example 5. Let's have a look at it, please. In example 5, we're told that the tangent of alpha is equal to 15 over 8, and we are to find the sine of alpha and cosine alpha without finding alpha. So here, what we're doing is we're given one ratio and we're asked to find the other two ratios without actually finding the angle. All right, so how I would do that? So let's start out with what they gave us. They gave us that tan alpha is equal to 15 over 8. Now, but tangent is equal to opposite over adjacent. All right, so the opposite is associated with what? 15, and the adjacent is associated with 8. So one more time, the opposite is associated with 15, and the adjacent is associated with 8. So from that now I can probably draw a triangle. So I'm going to draw a triangle. Right angle triangle, putting in the angle alpha. The side here is opposite, which is associated with 15. All right, this side is the hypotenuse, which we don't know. And the other side is the adjacent side, and this would be 8. So from tan, which is opposite over adjacent, the opposite side would be 15, the adjacent side would be 8. The side that we don't know is the hypotenuse. But if I know two sides of a right angle triangle, and I wish to find the length of the third side, all I need to do is to apply Pythagoras Theorem. Now, Pythagoras Theorem says c squared is equal to a squared plus b squared. That's the Pythagoras Theorem formula. And in this formula, c is the hypotenuse, which we don't know. A and b are the other two sides, which are what? 8 squared and 15 squared. 8 squared is 64. 15 squared is 225. When you add them, you're going to get 289. Now, the opposite of square is square root, and so x, which is the hypotenuse, which would be the square root of 289. You put that in a calculator, and x comes out to be 17. Once I know the hypotenuse, I can find sine and I can find cosine. So sine is opposite over hypotenuse, and so the sine of alpha is opposite 15 over hypotenuse 17. Cosine is adjacent over hypotenuse, and so the cosine of alpha would be adjacent 8 over hypotenuse 17. All right. So next we're asked to show that cosine square is equal to 1 minus sine square. First of all, the cosine, and notice you have what? The theta here, it should have been alpha. First of all, the cosine of alpha is equal to, the cosine of alpha is equal to
8 over 17.
8 over 17. So cos square alpha would be equal to 8 over 17 square, which would turn out to be 64 over 289. Now, if we work out, so what they're asking us to do is to work out what is 1 minus sine square alpha. And if it turns out to be 64 over 289, then we could say that cos square alpha is equal to 1 minus sine square alpha. So first of all, 1 minus sine squared alpha would be, let's separate them, would be 1 minus sine alpha is 15 over 17 square. So this is 1 over 1 minus 225 over 289. If I'm adding or subtracting fractions and the denominators are different, I must find the LCM, which is 289. 1 into 289 is 289. 289 times 1 is 289. Minus 289 into 289 is 1. 1 times 225 is 225, which turns out to be 64 over 289. So both cos squared alpha is 64 over 289, and 1 minus sine square alpha is also 64 over 289. Therefore, I can conclude that cos squared alpha is equal to 1 minus sine squared alpha. Because when I worked out both of them turn out to be equal to 64 over 289. All right, let's stop this one here.